That's when it's fun. Okay, verifying trig equations. So what we're going to do is we're going to take a look at an example, then we're going to talk about it. So our first example is cosecant theta times cosine theta, so just write that right next to it, equals cotangent theta. Okay, so we're still kind of doing the same stuff we did yesterday. We're still rewriting trig functions, but we know what we want it to look like. So you have a left side and you have a right side. You got to choose which side looks the most simple. Totally that. That's our target. We want to turn this into just cotangent theta, kind of like a geometry proof. All right, so let's kind of analyze what's going on here. Cosecant, what is cosecant the reciprocal of? Sine, so that's like 1 over sine, and then that's cosine. So when I change this to 1 over sine, that's going to be cosine over sine, which is the definition of cotangent. So I verbalized out loud with you what I would think in my head if I was keying this on my own. All right, so I know cosecant is this. And I'm not even writing the left side or the right side yet. I'm still working on the left side. So this is going to be cosine theta over sine theta. Boom, that's it. I know for sure that's cotangent. And I have just verified this equation. If this was a free response test or quiz question, you would have to show this verification, and you have to most certainly show that the right side matches the left side. That's verification. All right, let's look at another problem. Remember, I got 5 for you. Let's look at number 2. So for problem number 2 could be daunting unless you kind of read it ahead of time. So always read this stuff before you just start trying to change it. So sine squared theta, and then that is being multiplied by a set of parentheses. In the parentheses is 1 plus cotangent squared theta, and we want that to equal 1. Okay, so if you notice, you have terms that are squared, and you have a 1. Obviously, I'm leaving that alone. I want to make this turn into a 1. So if you have things that are squared and a 1 with it, y'all, it is this. There's something going on right here for sure. Look in the parentheses, 1 plus cotangent. What does 1 plus cotangent equal? Cosecant. So remember, y'all, that's cosecant in there. What's the cosecant reciprocal of? Sine. And do y'all know the answer to any reciprocals multiplied together? What does that equal? Yeah, what if I put this with it? Oh wait, down here. What does it equal now? It still equals 1. As long as they are reciprocals, they will always equal 1. Okay. So I'm going to substitute. I'm going to drop that, put what it equals. So this is going to be sine squared theta times cosecant squared theta equals 1. That is 1. 1 equals 1. That's it. That's what we're in the job of doing. And it doesn't have to be crazy hard if you just pre-think. Kind of analyze what's going on. Let's do another one. Let's kind of level up a little bit. That was so easy. Okay, example 3. This is going to be secant to the 4th power of theta minus secant squared theta equals tan to the 4th power theta plus tan squared theta. Alright guys, if you notice, they're pretty much balanced in terms of simplicity. Like that's two terms, that's two terms, that has exponents, so does that. So you're just going to have to choose which side you want to work on. And we can decide together as a class. Do y'all want to make secants look like tangents? Or do you want to make tangents look like secants? Do y'all want to work on the left side or the right side? Cool. I have not done this side yet. That's going to be good. Everybody's been choosing that side. All right, here we go. So they're both raised to an even power, which means they're both squares. But, y'all, these are only for 2's. So can I rearrange this side at all? Is there anything I can do to this before I start trying to mess with this? I don't want to change them as quotients. I don't want to write them as reciprocals. Factor it out. Factor it out. Let's factor it out. Now remember, I can't divide, because if I did divide, I'd have to divide the whole thing. And we're not messing with the other side. So let's just factor out tangent squared. So that was 4. I took 2 of them out. That leaves 2. I took all of that out, so that's going to be plus 1. Okay. So they're squared now. That's good. What does tangent squared equal? Secant squared minus 1. Because this has to move over there for tangent to be by itself. Y'all, tangent equals secant squared minus 1. So where we have these, I'm going to start dropping in what they equal, because then they're all going to be the same trig function. So remember, tan squared theta equals secant squared theta minus 1. So I'm going to take this out, and I'm going to put this in. But that's not the only tangent squared. I have another one. So in the parentheses, I have to write the same thing again. Dropping the tangent, putting in its substitution. Do y'all see what's happening in these parentheses? Do y'all see this? What's going on here? What's this? If I cover that up, would that help? What happens here? Yeah. So that's going to be, I'm just going to rewrite this first part in parentheses, because those two terms, remember it was tangent, those two terms are going to be multiplied by secant squared theta. So we're going to have to distribute, but like we're distributing kind of backwards. We're distributing this to these two. So secant squared times secant squared, that's going to be secant to the 4th theta. And then secant squared times negative 1 is negative secant squared. And we did it. That matches exactly. We don't have to rearrange the order or anything. That's how you do it.